Right, welcome back, dear students. This is continuation of straight lines. So in the last class, we have discussed various forms of the equation of this straight line, namely slope-intercept form. That is, y is equal to mx plus c, where m is the slope of the straight line and c is the y-intercept. And then point slope form. That is y minus y1 is equal to m into x minus x1, where m is the slope of the straight line and x1 comma y1 is the point on the straight line. And then the 2-point form, that is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. And this is the equation of the straight line passing through 2 points, namely x1 comma y1 and x2 comma y2. And then we have derived the equation of the straight line in the intercept form, which is x by a plus y by b is equal to 1, where a is the x-intercept and b is the y-intercept. And finally, we have observed that each of these forms can be reduced to a more general form, which is ax plus by plus c is equal to 0. This is called the equation of the straight line in the general form. Each of these equations, you can see that consists of an x term, a y term, and a constant term. A first degree x term, a first degree y term, a constant. Each of these equations contains a first degree x term, a first degree y term, and a constant term. That's why each of these can be reduced to this structure. That's why this is the equation of the straight line in the general form. Okay, now let's see a few examples how to derive the equation using the data given to you. So for example, find the equation of the straight line whose slope is 3 units and passing through the y-intercept is, and the y-intercept of the straight line is 5 units. Write the equation of the straight line. A simple answer is, you have the slope and you have the y-intercept. Straight away you can go for this structure. So y is equal to m, which is the slope of the straight line, 3 into x, plus c, which is the y-intercept, 5 units. And if you want to convert it to the general form, you can write it as 3x minus y plus 5 equal to 0. This structure. Suppose you are asked to find the equation of the straight line whose slope is minus 1 unit and passing through the point 1 comma 8. Find the equation of the straight line whose slope is minus 1 units and passing through the point 1 comma 8. So you have the slope and you have the point, so you can go for the point slope form. So the answer is y minus, our y1 is 8. So y minus 8 is m, which is the slope of this straight line, minus 1 into x minus, x1 is the x-intercept of this point, that is 1 unit. So on simplification, this becomes minus x, becomes plus x on the left side. So this is x plus y, and the constant of this is minus 8 here, and minus of minus 1, that is plus 1. That becomes minus 1 on the left side, so it is minus 9 equal to 0. So this should be the equation of this straight line whose slope is minus 1 units and passing through the point 1 comma 8. Ditto case with 2-point form and ditto case with intercept form. Suppose you are asked to find the equation of the straight line whose x-intercept is 3 units and y-intercept is minus 5 by 4 units. You are asked to find the equation of the straight line with the x-intercept as 3 units and y-intercept as minus 5 by 4 units. What should be the equation? We have the equation of the straight line in the intercept form here. So our a is the x-intercept, which is 3 units, and our b is the y-intercept, which is minus 5 by 4. Therefore, the equation of the straight line is x by 3 plus y by minus 5 by 4. is equal to 1. You can make the necessary simplification given to you in the general form to any of these forms. And forget about this one. You are not going to convert this equation to point slope form or 2-point form. You may be asked to convert the equation of this straight line which is in the general form to slope intercept form or the intercept form. And of course you have this normal form which we will discuss at a later stage. Okay, suppose you have a straight line, say 3x minus 4y plus 7 equal to 0. Convert this equation to the slope intercept form, which is y is equal to ms plus c. The simple logic shows that the left hand side you have this y term, first degree y term, and the quotient of this y should be equal to 1. So keep this y term on one side, the rest of the terms on the other side. So this can be written as 4y is equal to 3x plus 7, and then y is equal to 3 by 4 into x plus 7 by 4, and you can see that this is of the form y is equal to mx plus c. So the slope of the straight line is 3 by 4 units and the y-intercept of the straight line is 7 by 4 units. Similarly, reduce this equation to the intercept form. Right, what is the intercept form? The intercept form of the straight line is x by a plus y by b is equal to 1. And you can see that the x term and the y term should be on one side of this equality. On the right side, the constant should be equal to 0. So, how we are going to write this equation? The simple logic shows that this 3x minus 4y is equal to minus 7. And to make this constant 1, you have to divide the entire equation with minus 7. So that this becomes minus 3x by 7 plus 4y by 7 is equal to 1. I am dividing the entire equation with this minus 7. Now, write this expression or write this term as x by a. So minus 3x by 7 should be written as or can be written as x by minus 7 by 3 plus y by 7 by 4 is equal to 1. So this shows that the x-intercept of the straight line is minus 7 by 3 units and the y-intercept of the straight line is, 7 by 4 units, and this is of the form x by a plus y by b is equal to 1. Okay. Now, let's discuss something about the collinearity of the points. What do you mean by collinear points? Collinear means collinear. That means they exist on the same straight line. They coexist on the same straight line. Linear corresponds to line. So collinear points means the points on a same straight line. So if we have say 3 points, say x1, y1, x2, y2, and x3, y3. You may be asked to check whether the points are collinear or not. If they are collinear, you can always find a straight line passing through all the 3 points. So all the 3 points P, Q, R are on the same straight line. We say that the points are collinear. If you can't find a straight line passing all these 3 points, P, Q, and this R. No, the line passing through PQ doesn't pass through this point R. And the line passing through QR doesn't pass through the point P. Or the line passing through PR doesn't contain this point Q. So you cannot find a single straight line which is passing through all the 3 points. So it is impossible. Such points, we say that they are not collinear. They are not collinear. They are not on the same straight line. Mind you, if they are on the same straight line, they are in the same straight line, you can't find a triangle with these 3 as the vertices. The only triangle with these 3 points as the vertices is the triangle with area 0. So the triangle collapses to a straight line. Whereas in this case, you can always find a straight line, triangle with these 3 points as the vertices. And the area of this triangle is a positive quantity. Okay, so if the points are not collinear, we can find a triangle with the 3 points as the vertices with a positive area. If the points are collinear, the area of the triangle should be equal to 0. Now, how to check whether the points are collinear or not? There are various methods to this. The first method is, you can see that the line segment PQ and the line segment PR, they coincide with each other. Or the line segment PQ and the line segment QR are on the same straight line. Or the line segment QR and PR, they are on the same straight line. That means slope of PQ should be equal to slope of PR. That should be equal to slope of QR. That means with these 3 points, we can find 3 line segments PQ, QR and PR. All these 3 line segments should have the same straight slope because they are part of a same straight line whose slope is say m. Then this should be m, this should be m, and this should be m. So this is the easiest way to check whether the points are collinear or not. All that we have to do is take the first 2 points, find the slope of the line segment joining them. Take the second pair of points, find the slope of the line segment joining them, and you can see whether these slopes are equal or not. You need not go for the third one because that's not at all required. Why? Because if slope of PQ is equal to slope of PR, you need not go for QR because PQ and PR have a same common point P. So you can find only one straight line passing through a fixed point P and a fixed slope M. So QR should also have the same slope, that is an implied one. So of these 3, you need not check the slope of all the 3 line segments. It is enough you check the slopes of any 2 line segments, either PQ or QR or PR. Any 2. వీటిలో రెండింటి యొక్క slopes equal and prove చేస్తే that's enough. That's the first method. The other method is distance PQ should be equal to distance PR. In this case, distance PR should be equal to distance PQ plus distance QR. So you find the measurements of the line segment PQ, QR and PR. You find the measurement of this line segment, length of this line segment. Now you can see that if the points are collinear, the sum of 2 line segments must be equal to length of the third line segment. Whereas in this case, length PQ plus length QR should be strictly greater than length PR if they are not collinear. The simple logic is, if the points are not collinear, there is a triangle with the 3 points as the vertices. And if there is a triangle with the 3 points as the vertices, the sum of the lengths of the 2 line segments is sum of the sides of 2 sides of the triangle. And we know that this definitely exceeds the length of the third side. త్రిభుజంలో 2 భుజాల యొక్క సమ్ అంటే 2 భుజాల యొక్క మొత్తం మూడో భుజం కంటే న్యాచురల్గా ఎక్కువ ఉంటుంది. So PQ plus QR is strictly greater than PR. It cannot be equal to PR. So that gives the lines are collinear or not. So if PR is equal to PQ plus QR, or if PQ is equal to PR plus QR, and if QR is equal to PQ plus, that is, sum of 2 line segments is equal to the third line segment, the 3 points are collinear. If not, they are not collinear. The third one is prove that area of triangle PQR is equal to 0. We can prove that area of triangle PQR is equal to 0. If the points are not collinear, there exists a real triangle with a positive area. But if the points are collinear, the area of the triangle should be equal to 0. This point collapses to this straight line. Naturally, this triangle collapses to be a straight line. If this point collapses to this straight line, the area of the triangle reduces and ultimately it becomes 0. So area of the triangle is equal to 0. And you know the formula for the area of the triangle with these 3 points as the vertices. You already know the formula. What is the formula for the area of the triangle? The symbol for the area of the triangle, that is delta, is, you know the formula, that is modulus of half into, of course, half is a positive same. So half into modulus of this x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This should be the area of the triangle with these 3 points as the vertices. And if this area of the triangle is 0, the points are collinear. And if the area of the triangle is a positive quantity other than 0, the points are not collinear. There is another method, the fourth one. The other method is, you may find the equation of PQ. Find equation of PQ. The straight line PQ. Mind you, this is a line segment PQ, whereas this is straight line PQ. This is the straight line joining these 2 points or passing through the 2 points. And then you have to prove that the third point lies on the straight line. How can you check whether a point lies on a straight line? That means, how can you check whether the point, particular point, belongs to a straight line? The simple logic is, take the third point, x3 comma y3, substitute it in the equation of PQ. Substitute x3 in the place of x, substitute y3 in the place of y, and see whether the equation is balanced or not. If the equation is balanced, right, the third point lies on the straight line PQ. That is, third point also belongs to the straight line PQ. That means all the 3 points are collinear. If the third point doesn't satisfy this PQ, the equation of PQ, no, the points are not collinear. They show the diagram. That's the case. So, the last method is, you may find the equation of a straight line passing through any 2 of the points. You know how to find the equation of the straight line passing through 2 points. You have the formula. What is the formula? Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1, of course, 2-point form. So you can use 2-point form to find the equation of the line joining either these 2 points or these 2 points or these 2 points. You may get an equation of the form ax plus by plus c equal to 0. And you can substitute the third point on that equation. If the equation is balanced, write the points are collinear. If not, no, the points are not collinear. So these are various methods to check whether the points are collinear or not. Let's see one example. Let's see. One example. See whether the points 1 comma 2, 3 comma 4, minus 5 comma minus 4 are collinear. Check whether the points are collinear. Whether so-and-so points are collinear or not. This is a problem given to you. So you name the points. This is a point P, this is a point Q, and this is a point R. What is the easiest of the methods? To find the slopes of PQ and PR. Right? What is the slope of PQ? So you know the formula for the slope of a line segment joining 2 points. The simple formula is y2 minus y1 by x2 minus x1. So it is 4 minus 2 divided by 3 minus 1. And this 4 minus 2 is 2 and 3 minus 1 is 2. So 2 by 2 which is equal to 1. Similarly, slope of PR. You can go for PR or QR, whatever it is. So slope of PR is, this is P and this is R. So what is the difference of y coordinates? So this is minus 4 minus 2 divided by minus 5 minus 1. And this is minus 4 minus 2 is minus 6. And minus 5 minus 1 is minus 6. And this quantity is 1 unit. Now you can see that slope of PQ is 1 unit, slope of PR is 1 unit. So naturally, the 3 points PQ are collinear. Okay. What is the other method? What is the other method? You might find PQ plus QR is equal to PR, etc. So you find the distance PQ. So what is the distance between the 2 points PQ? The formula is square root of x1 minus x2 whole square, 1 minus 3, that is 2 square, plus 2 minus 4, that is 2 square. That quantity is root 4 plus 4, that is root 8. That can be written as 2 root 2. Root 8 is 2 root 2. Square root of 4 into 2. Root 4 is 2 and root 2. Okay, and then PR is, distance PR is, this is P and this is R. So what is the formula? Square root of x1 minus x2 whole square. This is 1 minus or minus 5. That is 1 plus 5, that is 6. 6 square plus y1 minus y2 whole square. This is 2 minus or minus 4. That is 2 plus 4, 6 square. That is 2 times 36. That is 6 root 2. And then the distance QR is equal to, again, this is Q and this is R. So what is QR? This is square root of x1 minus x2 whole square. This is 3 minus or minus 5. That is 3 plus 5. That is 8 square. Plus 4 minus or minus 4. That is 4 plus 4. That is 8 square. And this can be square root of 64 plus 64. That is 2 into root 64. That's 8 root 2. Now look, this is 8 root 2, this is 6 root 2, this is 2 root 2. You can see that QR is exactly equal to PQ plus PR. So we can see that QR, that is 8 root 2, is exactly equal to PQ plus PR, that is 2 root 2 plus 6 root 2, which is 8 root 2. Therefore, all the 3 points are collinear. This is another way of proving the points are collinear just by finding the distance between the 2 points, PQ, PR, QR, etc. Or alternatively, you can find the equation of this straight line passing through the 2 points, P and Q. You may substitute the third point. Let me show you. So, what is the equation of this straight line passing through the 2 points, P and Q? So, equation of PQ is equation of PQ. This is a 2-point form. So what is the formula? Y minus y1, that is 2, is equal to y2 minus y1, that is 4 minus 2, divided by x2 minus x1, that is 3 minus 1, into x minus x1 is 1 minus. Call it as x1 comma y1, and this as x2 comma y2. That's it. So on simplification, this becomes 4 minus 2 is 2 units, 3 minus 1 is 2 units, 2 by 2 is 1 unit. So this entire quantity is 1. So the equation is reduced to y minus 2 is equal to x minus 1. Alternatively, you can write it as x minus y. Take this y to the right side. So x minus y. Or minus 2, that becomes plus 2 on the right side. 2 minus 1 is 1, equal to 0. So this is the equation of this straight line, PQ. Now what next? You have to prove that the third point, minus 4 comma minus 5, minus 5 comma minus 4, also belongs to the straight line. Then the points are collinear. If it doesn't belong to the straight line, no, the points are not collinear. That's it. So substituting the point minus 5 comma minus 4 in this straight line. So x, in the place of x, you have to write minus 4, minus of, our y is minus 4, plus 1. That should be exactly equal to, you can see that this is minus 5 and plus 4 plus 1, that is plus 5, which is 0, and perfectly balanced. Therefore, all the 3 points are collinear. This is the way to prove the points are collinear. If the equation is not balanced, no, the points are not collinear. That's so simple. Okay. Next one. Certain conditions where the points are parallel, straight lines are parallel to each other, or the lines are perpendicular to each other, etc. So the condition that the two straight lines are parallel to each other is so and so. The condition that the two straight lines are perpendicular to each other is so and so, etc. So take the Cartesian coordinate system. This is x-axis, this is the y-axis, this is origin. Somewhere here you have this straight line, L1 equal to 0, right? Suppose you have another straight line here, L2 equal to 0. And if the two straight lines are parallel to each other, what should be the condition? The simple condition is, look, any straight line can be reduced to any of the forms. You may have the equation of the straight line in the general form, but you can reduce it to the slope intercept form, that is y is equal to ms plus c. Or in other words, you can easily find the slope of the straight line and the slope of the straight line. So, let the slope of the first straight line is m1 and the slope of the second straight line is m2. Now, if the two straight lines are parallel to each other, both are making same angle, theta, with the positive x-axis. And we know that by formula m1 has to be equal to tan theta. And by formula m2 also has to be equal to tan of the angle made by the right with the positive x-axis, which is same as this theta. That gives m1 is exactly equal to m2. So, what is the condition? That the two lines are parallel to each other. The simple condition is, if two straight lines are parallel to each other, their slope should be equal. Slope of the first line should be equal to slope of the second straight line. And you may ask, suppose the two lines are coinciding with each other. Why not? If these two lines are coinciding with each other, you move the straight line gradually so that it coincides with this one. Now, the two straight lines are coinciding with each other. There exists only one and only straight line. There are no two different straight lines. So, you don't need a formula for that. You don't need a condition for that. You have only one straight line. So, you don't need a condition that. Okay. So, if two straight lines are parallel to each other, what is the essential condition? M1 is equal to M2. That is, slope of the first line must be equal to slope of the second line. Okay. Right. Suppose the two straight lines are perpendicular to each other. Let this be the straight line L1 equal to 0. Let this be another straight line L2 equal to 0, where the angle between them is exactly 90 degrees. So what should be the condition? What should be the condition? That the two straight lines are perpendicular to each other. Again, did a case with this. Let the slope of the first line is m1. Let the slope of the second straight line is m2. Slope of the second straight line is m2. Now, look, if this angle made by the straight line, first straight line with the positive x-axis is theta 1, the angle made by the second straight line with the same positive x-axis, call it as theta 2. Call it as theta 2. What is the relation connecting these two? What is the relation connecting these two? Now, we can see that this angle is theta 1 and this angle is exactly 90 degrees because this is 90 and this is exactly 90 degrees. So, this is a right angle triangle. And if this one is theta 1 and this is right angle, naturally this has to be equal to 90 minus theta 1. But we know that this entire angle is how much? 180 degrees. So it is 90 minus theta 1 plus, and this theta 2 should be equal to 180 degrees, that is pi. That gives theta 2 is equal to 180 minus 90, that is 90 plus theta 1. So the relation connecting theta 1 and theta 2 is theta 2 is exactly equal to 90 plus theta 1. Okay, but we know that m1 is tan theta 1, m2 is tan theta 2. So let's apply tan on both sides. So that gives tan theta 1 is equal to tan of 90 plus, tan of theta 2 is equal to tan of 90 plus theta 1. That is, tan theta 2 should be equal to, and I have a formula in trigonometry, tan 90 plus theta 1 is, tan 90 plus theta 1 is minus cot. So it is minus cot theta 1. That is minus of 1 by tan theta 1. You know that cot theta 1 is 1 by tan theta 1. So that gives the relation tan theta 1 into tan theta 2 should be equal to minus 1. But what is this tan theta 1? That is m1. What is this tan theta 2? It's m2. So m1 into m2 is equal to minus 1. So the condition that the two lines are perpendicular to each other is m1 into m2 is equal to minus 1. So, if you have two straight lines with you, you can easily find their slopes m1 and m2, keep them aside. And just look at the slopes of the two straight lines. If they are exactly the same, straight away you can say that the lines are parallel to each other. If the product of the slopes is equal to minus 1, yeah, the straight lines are perpendicular to each other. Otherwise, you may find the angle between the two straight lines. We can go for that also using these relations. You have this relation here. Look, we have this relation here. Now look at this relation. Theta 2 is 90 plus theta 1. Or you can write it as theta 2 minus theta 1 is equal to 90. Okay. Now, suppose the lines are not perpendicular to each other. They are not perpendicular to each other. Suppose they are intersecting at an angle theta. This way. This is x-axis, this is the y-axis, this is horizon, this is the straight line L1 equal to 0, and this is the straight line L2 equal to 0. These two are intersecting at an angle theta. At an angle theta. How to find theta when you know the equations of the straight lines? So if the slope of the first straight line is m1 and the slope of the second straight line is m2, then tan theta should be equal to m1 minus m2 by 1 plus m1 m2 with a modulus sign, of course. So you are going to find the acute angle between the two straight lines. Mind you, when two straight lines are intersecting each other at an angle other than 90 degrees, four angles are created, and two of them are acute angles equal to each other, and two of them are obtuse angles equal to each other. So, while finding the angle between the straight lines, we are interested only in the acute angle. If this acute angle, if we can find this one, we can automatically find the obtuse angle. It is 180 minus of this, because if this is 60 degrees, this is 180 minus 60, 120 degrees. If this is 30 degrees, this is 150 degrees, etc. So, all that we have to do is find the acute angle between the two straight lines. And this is the formula. Tan theta is m1 minus m2 by 1 plus m1 m2. How we are going to find? We can derive this formula at a later stage. Just for the present, we just remember this one. Okay. So, if we have two straight lines in the plane, no matter whether they are parallel to each other or perpendicular to each other or intersect at an angle other than 90 degrees, all the cases can be discussed straight away. Right. And one more important concept is there. And look, that the equation of the straight line is ax plus by plus c equal to 0, which is the general form. Now, this is the x-axis, this is the y-axis, this is the horizon. Suppose the line is parallel to this x-axis. Suppose this line is parallel to this x-axis. What should be the structure of this straight line? We know that any straight line parallel to the x-axis will have its slope as 0. Why? Because this is the initial direction and you need to achieve the same direction to coincide with this direction of x-axis, straight line. So you need not rotate anymore. So the quantum of rotation now is 0. So if theta equal to 0 is, slope of the straight line is tan theta, which is tan 0. And you know that tan 0 is exactly equal to 0. That's why the slope of a straight line which is parallel to the x-axis should be equal to 0. Right. So this structure can be reduced to x is equal to constant. How can you arrive at this? The simple logic shows that. Look at this equation, ax plus by plus c equal to 0. Let's convert this equation to the slope-intercept form. You know that the slope-intercept form is y is equal to mx plus c. Okay, right? So this by is equal to minus ax minus c or y is equal to minus a by b into x plus minus c by b. So if you have a straight line as plus by plus c equal to 0, the slope of this straight line, this y is equal to ms plus c. You can compare this with this, then m is equal to minus a by b. This is the slope of this straight line, and the y-intercept is minus c by b. By the way, what is the x-intercept for this straight line? Get a guess with this. You can always reduce the equation to the intercept form. Ax plus by is equal to minus c. Divide both sides with minus c. And you can write this as x by minus c by a plus y by minus c by b is equal to 1 unit. So this is how the form x by a plus y by b is equal to 1. Whereas x-intercept is minus c by a units, y-intercept is minus c by b units. That's the case. So whenever we have a equation of a straight line in the general form, we can easily find the slope, we can easily find the x-intercept, we can easily find the y-intercept. What is the x-intercept? Minus c by a. Minus c by a. What is the y-intercept? Minus c by b. What is the slope? That's minus b by e. Minus a by b. Minus of x quotient by y quotient. So it's minus a by b is the slope of this straight line. Now, if the straight line is parallel to the x-axis, this quantity has to be equal to 0. Any straight line parallel to the x-axis, the slope should be equal to 0. So, m equal to 0, that's minus a by b equal to 0. That means a should be equal to 0. If a should be equal to 0, this equation is reduced to the structure by plus c equal to 0. Or alternatively, you can write this as y is equal to minus c by b. That is, the structure y is equal to 2. We have already learned that a straight line which is parallel to the x-axis should be of the form y equal to constant. Ditto case with the straight line which is parallel to the y-axis. If the line is parallel to the y-axis, this is the y-axis and this is the straight line parallel to the y-axis. So what is the condition? The condition is simple. A straight line which is parallel to the y-axis, the slope should be an undefined quantity. Why it is an undefined quantity? Because it makes an angle 90 degrees with the positive x-axis. And the slope of this straight line is m, which is equal to tan of this 90 degrees. And you know that tan 90 degrees is an undefined quantity. You have learned in the trigonometry. Tan 90 degrees is an undefined quantity. That is, the denominator is 0 and the value is abnormally large or abnormally small. So, this is an undefined quantity. That means the denominator should be equal to 0. So, in this case, m is an undefined quantity means denominator b has to be equal to 0. So, what happens to this equation if b happens to be 0? If b happens to be 0, the equation is reduced to ax plus c equal to 0 or x equal to minus c by a. That is the structure x equal to k. That is the structure x equal to k. Okay. Now, let's discuss the normal form of a straight line. Let's discuss the normal form of a straight line. What is the equation of this straight line in the normal form? A normal means perpendicularity. A normal to a straight line is a perpendicular to the straight line. So normal in the sense that it is a line segment perpendicular to something. That's simple. So look at this diagram. This is the x-axis. This is the y-axis. This is the horizon. Suppose this is the straight line L equal to 0. So, to find the equation of this straight line, you need two hints. Why the two hints? You recollect the names of the different forms of this straight line. What is the first one? Slope-intercept form. For that, you need just two hints. One is, what is the slope of this straight line? What is the y-intercept of this straight line? So you need two hints to find the equation of this straight line. What is the other one? Point-slope form. A point on this straight line and the slope of this straight line. You need two hints. What is the next one? Two-point form. A point on this straight line, another point on this straight line. You may find the equation of this straight line. Two hints. What is the next one? Intercept form. X-intercept is something and y-intercept is something. What is the equation of this straight line? You need two hints. So, in all the cases, to find the equation of this straight line, you need just two hints. Suppose you are not aware of the slope of this straight line. Straight line slope ఏంటో మనకు తెలియదు. దీని మీద పాయింట్ ఏమిటో మనకు తెలియదు. దీని తాలూకు ఇంటర్సెప్ట్స్ ఏంటో కూడా మనకు తెలియదు. కానీ స్ట్రైట్ లైన్ ఈక్వేషన్ కనుక్కోవాలి. వాడిచ్చిన హింట్స్ స్ట్రైట్ లైన్ కి సంబంధించిన హింట్స్ ఇవ్వలే. The information provided to us is not about the straight line. It is about the perpendicular to the straight line from the horizon. So, the data given to you is a slightly different set of data. Draw a perpendicular from the horizon to the straight line. A perpendicular to the straight line. Now it is given that the length of this perpendicular is p units. Whereas the angle made by this perpendicular with the positive x-axis is alpha units. I am not writing this theta here. Theta reserves for the angle made by the straight line with the positive x-axis, that is this angle. We denote this angle with theta. And this is angle made by not the straight line, with the perpendicular to the straight line with x-axis. So let's use a slightly different symbol, say alpha. So the two hints to find the equation of the straight line are not about the straight line, but about the perpendicular to the straight line from the horizon. So length of this perpendicular is p units, whereas angle made by the perpendicular with the x-axis is alpha units. What should be the equation of this straight line? Find the equation of this straight line. So that is the question. How can you find this? It's so simple. Using this information, you can find this point. And you can find this point as well. You can find these 2 points using this information. Once you have these 2 points, which are on the straight line, we can go for the 2-point form. Or we have this point means you have this measurement, which is x-intercept, and this measurement, which is a y-intercept. So you can straight away go for the intercept form. So how to find the coordinates of this point? Now look, this is a point on the x-axis. So naturally, the y-coordinate should be equal to 0. And this measurement is the x-coordinate of this point. So what is this measurement? It's very easy to find this one. You know one angle of this right angle triangle. Look, this is a right angle triangle. Whereas this angle is 90 degrees and this angle is alpha. You call this one as P, and you call this point as A, and you call this point as B. Okay. Now consider the right angle triangle OPA. OPA. Angle P is 90 degrees and angle O is alpha. You know the measurement of this one, that is the adjacent side to this alpha. So if this measurement OA is equal to P by cos alpha, this quantity is P by cos alpha. You got this point A now. Similarly, you can find the point B. Look, this is a point on the x-axis, y-axis. So the x-coordinate of the point should be equal to 0, whereas the y-coordinate of this point is this measurement. And how to find this measurement? Look, this angle is alpha. So what happens to this angle? This is 90 minus alpha. If this is 90 minus alpha and this is 90 degrees, this angle has to be equal to alpha. So this angle is alpha. What is this measurement which is opposite to this angle? Alpha. This is P units. And this is the hypotenuse for the right angle triangle. So from the right angle triangle, OPP, from triangle OPP, this sine alpha is equal to, sine alpha is opposite side, small p, divided by the hypotenuse, that is OB. That gives OB is equal to P by sine alpha. So this measurement is P by sine alpha. That is the coordinates of this point P will be P by sine alpha. Now you are going to find the equation of this straight line passing through the 2 points A and B. The 2 points A and B. The 2 points A and B. So you can go for the 2-point form. That is y minus y1 is equal to m into, y2 minus y1 by x2 minus x1 into x minus x1. Or alternatively, you know the x-intercept of the straight line which is p by cos alpha. You know the y-intercept of the straight line which is p by sin alpha. And you can go for the equation of the straight line in the intercept form. What is the intercept form? X by a plus y by b is equal to 1. That is x by a is the x-intercept, that is this measurement, which is p by cos alpha, plus y by the y-intercept, which is p by sin alpha, is equal to 1. Or you can write it as x cos alpha plus y sin alpha by p is equal to 1 or is equal to 2. So x cos alpha plus y sin alpha equal to p should be the equation of this straight line. You may ask, sir, the equation of this straight line should be of the form ax plus by plus c. Yeah, no doubt. This should be the equation of this straight line. This is exactly the same structure. You know that for a particular value of alpha, cos alpha is a number. Cos alpha root 3 by 2 or 1 by 2 or 1 by root 2 or something like this. Or 0.8 or 0.9 and something. So this is a number. A number into x plus a number into y is equal to a number. That is a constant. So this equation is of the form ax plus by plus c equal to 0. But here, this p is the length of the perpendicular from origin to the straight line. This is the straight line. Draw a perpendicular from the origin to the straight line. This is the length of the perpendicular. So, mind you, whenever you are writing the equation of the straight line in the normal form, this is called the equation of the straight line in the normal form. Why? Because the unknown quantities, this p and alpha, are the hints given to you to find the equation of the straight line. That is p and alpha. They are the information regarding the normal to the straight line. A normal to the straight line from the origin. That's why it is called the normal form. Okay. This p is the length of the normal or length of the perpendicular. Mind you, the length of the perpendicular p has to be always a positive quantity. It has to be always a positive quantity. Make sure that the quantity on the right side is always a positive quantity. Okay. And the quotient of x should be cos alpha and quotient of y should be sin alpha. And you know that both cos alpha or the sin alpha, they are the quantities in between -1 and +1. You know that cos alpha lies in between -1 and +1 and sin alpha lies in between -1 and +1. Moreover, cos square alpha plus sin square alpha should be equal to 1. These are the conditions that have to be satisfied by the numbers. So, what will be the structure? The structure is x cos alpha plus y sin alpha equal to p. But what if you have the equation in the general form and you are asked to convert it to the normal form? General form of straight line equation is normal form to marchandi ante. So change the equation of the straight line. 3x minus 4y plus 7 equal to 0. Convert this equation to the normal form. So what is the normal form? X cos alpha plus y sin alpha equal to P. Look, the constant term should be on the right side. On the left side you have x and y terms. So it should be written as 3x minus 4y is equal to minus 7. And here you have to remember this point. P should be invariably a positive quantity. So the quantity on the right side should be a positive quantity. So that's why it has to be written as minus 3x plus 4y is equal to 7. So you may think that this is x into cos alpha plus y into sin alpha equal to P. No, this is not the case. This can never be equal to cos alpha, this can never be equal to sin alpha. Mind you, sin alpha can never be equal to 4. We know that sin alpha lies in between minus 1 and plus 1. This quantity should be strictly less than or equal to 1 and greater than or equal to minus 1. Similarly, this quantity. But you know that this is 4 which is far greater than this 1. Minus 3 which is far less than this minus 1. How can you change these quantities so that the quantities lies in between minus 1 and plus 1? That you can do by dividing the entire equation with square root of a square plus b square. This is minus 3 square plus 4 square. So that this becomes normal. This is 9 and 16, 25 and square root of 25 is 5 units. So it is minus 3 by 5 into x plus 4 by 5 into y is equal to 7 by 5. Now look, x cos alpha plus y sin alpha is equal to P. P is a positive quantity, this is sin alpha and this is cos alpha. How do you know that this is sin alpha and this is cos alpha? Because sin square alpha plus cos square alpha has to be equal to 1. What is this sin square alpha? 4 square by 5 square. What is this cos square alpha? 3 square by 5 square. So it is 4 square by 5 square plus 3 square by 5 square which is 25 by 25 which is exactly equal to 1. So imagine a right angle triangle. Imagine a right angle triangle. If this is alpha units, if one angle, this is cos alpha, this angle automatically, this quantity automatically has to be equal to sin alpha. If this is sin alpha, this quantity automatically happens to be cos alpha. Right. Now what this signifies? This cos alpha is a negative quantity, sin alpha is a positive quantity. That shows the angle made by the perpendicular with the positive x-axis is greater than 90 degrees. So if the angle is greater than 90 degrees but less than 180 degrees, sin is a positive quantity, cos is a negative quantity. How can be that case? I will show you. This is x-axis, this is the y-axis, this is the horizon. Suppose this is the straight line. This is the perpendicular, P, makes an angle alpha. If alpha is less than 90 degrees, the straight line is somewhere like this. If the straight line is exactly like this is the perpendicular, and this angle is exactly equal to, alpha is exactly equal to 90 degrees. Suppose the straight line is somewhere like this should be the perpendicular, and this is the length of the perpendicular P, whereas this alpha is greater than 90 degrees. So if alpha is greater than 90 degrees, cos alpha is a negative quantity, whereas sin alpha is a positive quantity. Suppose the straight line is something like this. Draw a perpendicular from this to the straight line. This is the normal, and the length of the perpendicular is P units, and this entire quantity should be equal to this alpha. This is greater than 180 degrees, but less than 270 degrees. And in this case, both cos alpha and sin alpha, they are negative quantities in the third quadrant. Suppose the straight line is somewhere here. Draw a perpendicular from the line to this x-axis. This is the normal, whose length is P units. And this quantum of rotation is this one, that is greater than 270 degrees. But if alpha is greater than 270 degrees, whereas in the fourth quadrant, cos is a positive quantity, whereas sin is a negative quantity. So, the quotients of x and y in the form of sin alpha and cos alpha, they may be positive quantities, they may be negative quantities, one may be positive, one may be negative. If both are positive quantities, this should be the straight line, the shape of the straight line and the location of the straight line. If cos alpha is negative, sin alpha is positive, this should be the location of the straight line, somewhere here, like this. The quantum of rotation is greater than 90 but less than 180 degrees. If both are negative quantities, this should be the location of the straight line. The quantum of rotation of the horizon normal from the initial axis should be greater than 180 degrees but less than 270 degrees. Data occurs for the last 1 hour. And this is how you can reduce the equation of the straight line in the general form to the normal form. And finally, you have to write one more thing. Where this is of the form. This is of the form x cos alpha plus y sin alpha is equal to p, where p is equal to 7 by 5 units. P is equal to 7 by 5 units. Cos alpha is equal to minus 3 by 5 and sin alpha is equal to 4 by 5. And you need not write these two quantities separately. Instead of writing these two quantities, single quantity, which is tan alpha is equal to sin alpha by cos alpha. That's 4 by 5 by minus 3 by 5. So it is 4 by minus 3. A caution. Always keep the signs attached to the numbers. Don't bring this negative sign to this. Don't write it as minus of 4 by 3. Always keep it as 4 by minus 3. If it is minus 4 by minus 3, better write it as minus 4 by minus 3 instead of writing 4 by 3. So keep the signs with the corresponding numbers. Don't merge the signs. Or don't write the absolute value of that one. Because this negative sign with minus 3 indicates that the angle made by the normal with the initial line is greater than 90 degrees but less than 180 degrees. Alpha is greater than 90 but less than 180. That's why cos alpha has to be a negative quantity. That should be the case. Okay. And so tan alpha is 4 by minus 3, or you can write it as alpha is equal to tan inverse 4 by minus 3. So while converting this equation to the normal form, finally you have to present what P is and what alpha is. So you have to write P is equal to 7 by 5 units, whereas alpha is equal to tan inverse of 4 by minus 3. That should be the case. So this is a normal form of this triangle. Okay. So we conclude for this time now. We will continue it in the next class. See you again. Thank you.
Hi, this is B. Chiranjeev, Junior Lecturer in Physics, APR JC Taitipudi. In this video lesson, Units and Measurements, I will teach about the very short answer type questions, very important for intermediate public examination. In this, as per the weightage given by the Board of Intermediate Education, one 2-mark question will come from this particular topic. So let us discuss about the very short answer type questions. Now let us observe the first question, that is, distinguish between accuracy and precision. See, the accuracy refers to the closeness of the measured value to the true value. This indicates how close the measured value to the true value. If it is very close to the true value, then its accuracy is more. And when you talk about precision, it is the closeness of the measured values of repeated measurements of physical quantity. Repeated measurements. So if you take several measurements, then it is the closeness of the measured values of repeated measurements of physical quantity. And when you observe the second point, it depends on the minimization of errors, accuracy. So if you just minimize the error, then you can minimize, the accuracy will be more. And in case of precision, it depends on the least count of the measuring and the sensitivity of the measuring instrument. Least count. For example, more the least count, it will be the more precise instrument. For example, out of a vernier calipers and screw gauge has more precision because its least count is 0.001 centimeter and vernier calipers has the least count 0.01 centimeter. So the precision depends upon the sensitivity of the instrument. The sensitivity, more sensitive, more precise. So these are the two differences you have to write down. One for one difference carries 1 mark. So two differences carries 2 marks. And now let us go to the next question. What are the different errors that can occur in the measurement? See the different types of errors. We have to observe the different types of errors. One is systematic error. Systematic error means if the errors are always in one direction, known as systematic errors. So one direction means if the readings are getting periodically with the same direction, that is for positive error, say for example screw gauge positive error, the error is repeated systematically. That is what is called systematic errors. And random errors, the fluctuations in the experimental conditions which cannot be predicted, which leads to random errors. Say for example line voltage, suddenly the voltage increased, it leads to error. See the temperature suddenly decreased or the atmospheric pressure changed. These are all the unpredicted conditions which leads to the random errors. And the next one is gross errors. See, the gross error means it is the mistake committed by the observer while taking the measurements. So, irregular taking of the measurements. It is the so we can do in 3 different ways. One is by improving experimental techniques. We have to improve the experimental techniques by selecting better instruments. We have to choose the good instrument. By removing personal bias as far as possible. So the gross errors, that is personal errors, that is to be eliminated. So by doing these 3, we can eliminate the systematic errors. And fourth question, illustrate how the result of measurement is to be reported indicating the error involved. Say, for example, in this question we have, say temperature of one body is 20 degrees plus or minus 0.5 degrees centigrade. So this is the way in which represent the measurement including with error, possible error. And the temperature of the second body 50 degrees centigrade plus or minus 0.5 degrees centigrade. This is error. This indicates error. And the temperature difference between these two bodies delta T is equal to T2 minus T1. So what we have to do? We have to subtract 50 minus 30, that is equal to 20 degrees centigrade. And when you come to the question of error, errors are always to be added. Errors are always to be added. So error due to the first one and the second one. So 1 degree centigrade. So this is how we have to represent the total result as, this is 20. So the result is 30 degree centigrade plus or minus 1 degree is possible error. So this is the result, the way in which you have to represent the result. First, the main value with the error. And the fifth question, what are significant figures and what do they represent when reporting the result of the measurement? See, the significant figure means the digits of number representing a measurement that are definitely known, that is reliable, plus one more digit added at the end of the number, that is estimated, or called significant figures. See, for example, length of some body is say 4.57 centimeters. In this, there are three digits 4, 5, 7. 4 and 5 are significant and they are reliable, whereas 7 is uncertain digit. This third one is uncertain digit. But this length has three significant figures. Out of these three, two are reliable and one is uncertain. This is how we have to represent the significant figures. We can consider this as a good example for representing the significant figures. See, in the sixth question, distinguish between fundamental units and derived units. Fundamental units and derived units. Units of fundamental physical quantities are fundamental units, and units of derived physical quantities are called derived units. Example, length is a fundamental quantity, its unit is meter, so it is a fundamental unit. Mass is a fundamental quantity and the unit of this mass is kilogram, it is a fundamental unit. Similarly, derived quantity. Example, velocity is a derived physical quantity, its unit is meter per second. So it is the derived unit. And density is a derived quantity and the unit of this derived quantity is derived unit, that is kilogram per meter cube. And now let us go to the next question. Why do we have different units for the same physical quantity? See, there are several systems, CGS system, metric system, and FPS and MKS. So different countries, they use different types of measurements, adopt. That is, see, for example, distance between the sun and the earth, an astronomical unit, it is very long distance. So its unit is 1.5, 1 AU, astronomical unit is the unit of length, 1.5 in 10 power 11 meters. So instead of saying 1.5 in 10 power 11 meters, we simply say 1 AU. 1 angstrom is equal to 10 power of minus 10 meters, very, very less, very small length. That is why unit we adopt for the same length in different cases. In one case it is astronomical unit and in another case it is angstrom. So this is how we adopt the measurements for different sizes. In the eighth question, let us observe the question eighth one. What is dimensional analysis? say a method of analysis in which physical quantities are expressed in terms of their fundamental dimensions. So a physical quantity expressed in terms of their fundamental quantities raised with suitable powers. So this is what is called dimensional formula, and this method used, this dimension analysis can be used to check the dimensional consistency of equation. There are several applications. Dimensional consistency of equation, or to check the correctness of the given equation, or we can convert the system of one unit into another system, and we can also obtain the relation between different physical quantities. And now let us go to the next ninth question. How many orders of magnitude greater is the radius of the atom as compared to that of the nucleus? See, actually, how many orders of magnitude greater is the radius of the atom? Normally, the radius of the atom is greater than the radius of the nucleus. So, how many times, how many powers of tens it is greater? See, actually, the size of the atom is in the order of 10 power minus 10 meters, and the radius of the nucleus is 10 power of minus 15 meters. So, what is the difference of these two? Hence, the radius of atom is greater by 10 power 5 times orders as compared to that of the nucleus. So now the last question is, express unified atomic mass unit in kilograms. So this is what is called atomic mass unit. This is also unit of very small sized particles. So one unified atomic mass unit, simply we call it as 1 AMU, atomic mass unit, is equal to 1.66 into 10 power of minus 27 kilograms. So this is all regarding some short answer questions, very short answer. These questions are very, very important for public examination. Now let us solve some problems. Now observe this problem. In the expression P is equal to E L square m power minus 5 G power minus 2, the quantities E is energy, L angular momentum, M mass, and G universal gravitational constant. Show that P is the dimensionless quantity. We have to prove that this P is dimensionless quantity. So for this, what you have to do is, first of all, we have to write down the dimensional formulas of each physical quantity. So what is the dimensional formula of energy? E is equal to, dimensional formula of energy is equal to m power 1 L square T power of minus 2. Next, what is the dimensional formula of angular momentum? This is L, angular momentum is equal to m power 1 L square T power of minus 1. And mass, dimensional formula of mass is equal to m power 1. And the dimensional formula of gravitational constant, G is equal to m power minus 1 L cube T power of minus 2. So this is how we have to write down the dimensional formula of each physical quantity given in the equation. Now let us substitute all these values in the equation P. Now let us write down the values in the equation P. P is equal to E power 1. So m power 1 L square T power of minus 2 whole power 1 into L m power 1 L square T power of minus 1 whole square into m power of minus 5 into acceleration due to gravity m power minus 1 universal gravitational constant, m power minus 1 L cube t power of minus 2 whole power of minus 2. Now let us simplify this equation. So m power 1 L square t power minus 2 m square L power 4 t power minus 2 m power of minus 5 m power of m square L power of 3 2s are 6 t power of minus plus 4. Now let us observe here it is minus 5 and how many mass are there? M square 2 2 4 1 5. So I write here m power of 5 into m power of minus 5. This is one mass is complete. L square 2 4 6 L power of 6 into L power of minus 6. So L is completed. Time t power of minus 2 t power of minus 2 t power of minus 4 into t power of 4. So this become m power of 0 L power of 0 t power of 0. So now we can write down that this is P is dimensionless. Here P is dimensionless quantity. Dimensionless quantity. This is how we have to prove the equations. This equation we can prove that it is dimensionless quantity. So this is the way in which we have to solve the problem. Now let us observe the next problem. Now let us solve the second problem. If the velocity of light c Planck's constant h and the gravitational constant g are taken as fundamental quantities, then express mass, length and time in terms of dimensions of those quantities c, h and g. So what you have to do is we have to express the mass is proportional to r in terms of fundamental quantities. So mass is equal to, we have to write down c power x and the another quantity h power y and g power z. And what is the dimensional formula of this mass? M power 1 L power 0 t power 0 is equal to c velocity. What is the dimensional formula of velocity? L power 1 t power of minus 1. This is the dimensional formula of c. What is the dimensional formula of Planck constant? M power 1 L power square t power of minus 1. What is the dimensional formula of gravitational constant? M power of minus 1 L cube t power of minus 2. These are the quantities, dimensional formulas. Now what you have to do? We have to substitute here the values. I just write here m power 1 L power 0 t power 0 is equal to c L power 1 t power of minus 1 whole power x into Planck's constant m power 1 L square t power of minus 1 whole power y into gravitational constant m power minus 1 L cube t power of minus 2 whole power z. Now let us separate the mass, length, time. So L power x here L square 2y. So I write here this is 2y and this is 3z. I write here this is 3z into mass m power y minus z into time t power of minus x minus y minus 2z. So we have to compare this with m power 0, m power 1, L power 0, t power 0. So by comparing the base, the powers are the powers of L both sides are the powers of m. Y minus z is equal to 1. What about this one power of length? X plus 2y plus 3z equal to 0. What about the powers of time? Minus x minus y minus 2z is equal to 0. So these are the equations we obtained from this one. Now if you add these two, on adding, what happened? On adding, the x is cancelled, so you will get y and plus z equal to 0, and we have another equation here, y minus z is equal to 1. Again you add these two equations. On adding these two, you will get these two can be cancelled. 2y is equal to 1, so y is equal to half. So this is the value we obtained here, y is equal to half. Next, we have to find the value of z. See, once you know y minus z is equal to 1, here y minus z is equal to 1, but y is already half. Half minus z is equal to 1. So minus z is equal to 1 minus half. So that is equal to half. So z is equal to minus half. So y is half, z is minus half. And we have another equation that yz. You substitute somewhere here. For x we have to find. For x plus 2y plus 3z is equal to 0. X plus 2y plus 3z is equal to 0. That is the formula. Now what we have to do? X plus 2 into, what is the value of y? Half plus 3 into, what is the value of z? Minus half equal to 0. So these two cancelled. So x plus 1 minus 3 by 2, 1.5 is equal to 0. So 1 minus 1.5 is 1 and 1 half minus half. X minus half equal to 0. This implies x minus half equal to 0. Therefore, x equal to half. So x equal to half, and y is equal to half, this x equal to minus 1.5 x. Now let us see the, so now we can write down the relation that mass is equal to, here mass is equal to c power x, x is half h power y, y is also half, and g power minus half. So now you can write down mass is equal to under root ch by g. This is the relation for mass in terms of velocity, Planck's constant, and universal gravitational constant. So this is how we can get the relation for mass with the considered as fundamental units: velocity of light, h Planck's constant, and gravitational constant z. Now let us establish the relation for length. Now let us observe, when you are going to establish a relation for length, now what you have to do? We have to write down here the relation for length. So what you have to do here, mass is 0, length is 1, time is 0, the remaining factors are same. So what you have to, while comparing here, mass is 0, length is 1. So for mass, y minus z is equal to 0, and for length, x plus 2y plus 3z is equal to not 0, this is 1, and minus x minus y minus 2z is equal to 0. So simply on adding, the same procedure we are adopting here, on adding, what happened? X cancelled, and y plus z is equal to not 0, this is 1, but y minus z is already given 0. So again you are adding this, you will get z cancelled. So 2y is equal to 1, y is equal to half, again you got y is equal to half. But now let us observe the remaining part here. What you have to do? We have equation y is equal to half and y minus z is equal to 0. Y minus z equal to 0. But y is half. So half minus z equal to 0. So minus z equal to minus half. That implies z is equal to half. So y is half, z is half. So from these two, you can find the value of x. You take some value, minus x, minus y, minus 2z is equal to 0. So minus x minus, what is y? Half. Minus 2 into, what is z? Half. Equal to 0. So now what happened here? 2 cancel. So minus x minus half minus 1 is equal to 0. So now this is minus 1.5. Now this become minus x minus 3 by 2 equal to 0. This implies x equal to minus 3 by 2. These are the values we obtained. The first one is y, and the x, y, and z. These three values. Now, how do we represent the equation? The equation becomes, see, the equation becomes L is equal to c power x. X is minus 3 by 2, or c cube into minus half. I write here c cube whole power minus half into h power y half g power z half g power half. Then what happened? L is equal to, these are positive values. I write here under root h into g by c cube. So this is the relation for L. If you consider that the gravitational constant, Planck's constant, and velocity c cube. Now one more concept we have to consider. The time is to be expressed in terms of c, h and z. The time. How do we express the time? The same equation. What you have to do? You have to observe that L is not, we have to consider here it is time is equal to c power x, h power y, e power z, m power 0, L power 0, but here time power 1. The remaining are same. So m power 0, L power 0, t power of 1. Then what happened now? Mass y minus, and for L, x plus 2y plus 3z is equal to 0, and minus x minus y minus 2z is equal to 1. So by adding, x cancelled, then y plus z is equal to 1. But y minus z is 0. So 2y is equal to 1. Y is equal to half. For this case also y is equal to half. And now let us find the value of z. Actually y minus z equal to 0. So half minus z equal to 0, and again z is equal to half in this case also. Now we are going to find the value of x. So what will be the value of x here? Now let us take this equation. This is not 0. This is actually 1. X minus y minus 2z. This is 1. So now let us solve this. This is not 0. This is 1. This is not 0. This is 1. Now minus x minus half minus 1 is equal to 1. So minus x minus 3 by 2 is equal to 1. So what happened now? Minus x equal to 1 plus 3 by 2. 1 plus 3 by 2. That is equal to 5 by 2. And now x equal to minus 5 by 2. So from this you can write down x equal to minus 5 by 2. X is minus 5 by 2. That's the value we obtained here. So x is minus 5 by 2. Y is half. Z is half. Then how do you write the expression? Time is equal to under root, which one has x as, so this one has to c power 5. So I write here hg by c power 5. So this is the relation for the time expressed in terms of h, g and c. Now this is how we can represent the mass, length, time with velocity c, Planck's constant h and gravitational constant z, which are considered as fundamental quantities. So in different cases. Now let us go to another problem. So in this problem, The error in the measurement of radius of sphere is 1%. What is the error in the measurement of volume? So actually, the error in the measurement of radius leads to error in the volume, because volume of the sphere is equal to 4/3 pi r cube. This is the formula. Of course, 4/3 pi is a constant. So the error in the this one volume percentage error, delta V by V into 100 is equal to, this is constant, nothing will be changed, 3 into delta R by 3 times. So this is how we can find the error raised in the measurement of volume. Now let us go to the next problem. Now the fourth problem. Percentage error in the mass and speed are 2% and 3% respectively. What is the maximum percentage error in kinetic energy? See, actually, we know the relation for kinetic energy is equal to half mv square. So the error in mass and the error in velocity leads to error in kinetic energy. So Ke delta Ke by Ke into 100 is equal to delta m by m into 100 plus 2 into delta V by V into 100. So this is given, percentage in mass is 2% plus 2 into the percentage in velocity, speed is 3. So what is the total percent now? 2% plus 6%. So total it is 8%. So the error in speed 2%, the error in speed, the error in mass is 2%, the error in speed is 3%. These two leads to the percentage error in energy, kinetic energy. See, the time period of simple pendulum has a relation 2 pi under root L by G. This is the formula for the time period of a simple pendulum. So the percentage error in time period of simple pendulum, delta T by T into 100 is equal to, this 2 pi is constant, L power half and Z power minus half. You can write down this as half into delta L by L into 100. Even though it is in denominator, we have to add the errors. Always we have to add the errors. So even though the T is equal to 2 pi into L power half into Z power minus half, but even we have to add this one, plus half into delta G by G into 100. So the percentage error in length is given, that is 2%. Half into 2% plus half into 3%. Now this become 1% plus this become 1.5%. So totally this become 2.5%. So the error in the time period leads to 2.5%. So this is how we have to solve the problem in such case. Now let us observe the sixth problem. Find the resistance if voltage V is equal to potential difference. V is equal to 100 plus or minus 5 volts and current is 10 plus or minus 2 amperes. So for this what you have to do, we have to express the result with error. Different, and actually resistance is equal to, actually Ohm's law, according to Ohm's law, V is equal to IR. So there R is equal to V by I. So what is the value of R here? R is equal to V. V is how much? 100 volts by I, 10 amperes. That is equal to 10 ohms. This is the main part. And regarding error, errors are always to be added. Errors are always to be added. Errors are always to be added. To be added. So what is the error here? 5. What is the error here? 2. So error in resistance is equal to error due to voltage plus error due to current. So that is equal to 5 plus 2 is equal to 7. If you want to express it in percentage, you have to write down 7%. Then what is the value of R here? The resistance expressed as the main value 10 ohms plus or minus 7 ohms. This is the way in which you have to represent the resistance. Now let us observe the next problem. 7th one. The temperature of two bodies measured by a thermometer are T1 20 plus or minus 0.5 degree centigrade, T2 is equal to 50 plus or minus 0.5 degree centigrade. Find the temperature difference and the error therein. So let us observe the solution for this. Actually, we have to find the delta T is equal to T2 minus T1. What is actually T2 here? It is 50 minus 20. This is the main value, 30 degrees Celsius. But what about error? Errors are always to be added. Error due to this T1 is 0.5 plus error in the second one is 0.5 is equal to 1 degree Celsius. Error is. So what is the temperature difference now? The total value expressed as 30 degrees Celsius plus or minus 1 degree centigrade. So this is the temperature difference with the error represented. So this is how we have to this temperature difference. This is temperature difference, and this is the main part in the difference of temperature, and this is the error. Errors are always to be added. Error in the first reading and error in the second reading are to be added. Okay, this is how we can solve problems. Thank you.